This is the Molarity Worksheet that I promised I would put solutions to. I've decided that I need to do this with my camera on a piece of paper because the quality of the video is going to come out better if I don't run it through my computer first. So it's a little bit low tech, but I don't have Khan Academy money. Here we go. So first one, molarity of a solution that contains 0.00372 moles of hydrochloric acid in 2.39 times 10 to the negative second liters of solution. Okay, so molarity equals moles of solute over liters of solution. So right away I can see I already have moles here. I actually don't have to convert units to moles. So I can just do 0.00372 moles of HCl. And of course, chemistry teachers love to throw these sorts of challenges at you where you have to convert between liters and milliliters, or this would be a centiliter. Really all we need to do is move this over two places, 0.239 liters. So I take those two numbers, 0.00372 divided by 0.0239, and I get I got a very large number here, but remember, I'm only really able to go out three significant digits, so 0.156 molar HCl is my answer for that particular problem. And I apologize, I'm writing a little sideways just because I have my tripod set up here, so it should be legible. I'm checking on the screen and it looks like everything is okay, so let me continue like that. A flask contains 85.5 grams of sucrose in 1.00 liters of solution. So in this particular case, I need moles. I already have liters of solution. So I need to find the gram molar mass of sucrose, which would be 12 times 12 plus 22 times 1 plus 11 times 16, which means 144 plus 22 plus 176 342 grams per mole. And then I'm going to do 85.5 grams of sucrose times 1 mole over 342 grams. I'm always trying to cancel out my units, so I put it on the top and the bottom, and then what are the units I want to keep. Remember, molarity is moles per liter, moles of solute per liter of solution. So in this case, I want to cancel out my grams, and in this case they do cancel out. If I had this flipped over, grams on top, moles on the bottom, well then I'm going to get grams squared, which does not make any sense. And then I have moles on the bottom, and again, what am I going to do with that? So, in this particular case, now I have 85.5, and then I divide that by 342, and I get 0.25. Now, since I have three significant figures here, 0.250 moles, and since molarity equals moles of solute per liter of solution, it's now 0.250 moles over 1 liter. So my molarity is 0.250 molar solution. Okay. Next one is a beaker contains 214.2 grams of osmium-3 fluoride in 0.673 liters, 0.0673 liters of solution. What is the molarity? So again, grams to moles. Osmium 3 fluoride. That means the charge on osmium is 3, which means I need 3 fluorides to balance that. Now, I have to jump and get my periodic table. So I'm according to my periodic table now. Osmium is 190.2 plus 3 times 19 which gives me 247.2 grams per mole. So now I can transform this into moles by canceling out my grams. I end up getting 214.2 divided by 247.2, which is 0.866. Using 4 significant figures here, 0.8665 moles of osmium 3 fluoride. Now from there, I have it for a certain number of liters of solution, which in this particular case would be 0.0673 liters. Once I do that, that will give me my molarity. So using the number I did before, of course I'm going to discount these extra digits, but divided by 0.0673, I get 12.875, which would be the same as 12.88. But really I'm only allowed to use 3 significant figures, so that becomes 12.9 molar osmium fluoride. Osmium 3 fluoride to be more specific. Okay, now I need to readjust. Again, when I can get Khan Academy equipment, I'll be a little less primitive, but for the time being, here we are. So let me slide it up a little bit more. That is all of the problems on the bottom part of the sheet. I'll tape this down so it doesn't move. Can we see everything? Yeah, again, I apologize, things are a little bit off to the side, but I have to keep this tripod with the camera. So, a beaker contains 36.45 grams of ammonium chlorite, not ammonium chloride, in 2.36 liters of solution. So first I need to know what ammonium chlorite is, which ammonium is that. Chlorate would be ClO3 with a -1 charge, so chlorite is ClO2 with a -1 charge. Ammonium chlorite, they are now balanced. That is my formula unit for ammonium chlorite. So I have 36.45 grams of this in 2.36 liters of solution. But first, I need to remember molarity again is moles of solute per liter of solution. So I take this, I need to change it into moles, which means I do 1 mole over the gram molar mass. Here we have 14 plus 4 plus 35.45 plus 32, which is 18 plus 35.45 plus 32 equals 85.45. Okay. So 36.45 divided by 85.45 gives me 0.46. We'll call that 0.462. 0.4266 moles, because my grams cancel out, all I have are moles. So 0.4266 moles of ammonium chlorite. So that is how many moles in 2.36 liters of solution. So to find my molarity, I divide this by 2.36 liters, which means, keeping it to the proper number of significant digits, which would be 3, this is 0.181 molar solution. Now I see that my battery is starting to go down, so I have to stop this for a moment and get my video camera plugged in. One moment, please.